Oftentimes we need to be able to convert from polar coordinates to rectangular coordinates and vice versa. The following theorem provides a means for accomplishing this. If P is a point with polar coordinates r, theta, the rectangular coordinates x, y of P are given by x equals r cosine theta and y equals r sine of theta. So let's go through an example where I'm given the point 6 comma pi over 6, and this is given in polar coordinates. So r is 6 and the angle theta is pi over 6. To help you visualize what this is going to look like, there's my polar axis. I draw my angle of pi over 6 and then count 1, 2, 3, 4, 5, 6 units out on the terminal side, and there's my point 6 comma pi over 6. We're going to convert this polar coordinate into rectangular or Cartesian coordinates. Remember, the x-coordinate is r cosine of theta. So that's going to be 6 times the cosine of pi over 6. You should recall that the cosine of pi over 6 is the square root of 3 over 2. So I get 6 times the square root of 3 over 2, which is 3 root 3. The y-coordinate is going to be r times the sine of theta. So that's 6 times the sine of pi over 6. Call the sine of pi over 6 is 1/2. 6 times 1/2 is 3. So if I was to superimpose a rectangular coordinate system on the graph that we have drawn here in polars, remember the polar axis coincides with my x-axis, that would mean that this point is 3 root 3, and this point right up here is 3. So that point is 6 comma pi over 6 in polars, or 3 root 3 comma 3 in rectangulars. Let's do one more example where I'm given the point is -4 comma negative pi over 4. Remember, what this is going to look like is I'm going to have my polar axis. I draw my angle. Well, that wasn't very good angle, but I draw my angle at negative pi over 4, and then I go 4 units in the opposite direction. So that would be 1, 2, 3, -4. So it would appear that my values of x and y are going to be in the third quadrant. Let's see if that's the case. X equals r cosine of theta. So that's -4 times the cosine of negative pi over 4. Cosine of negative pi over 4 is positive square root of 2 over 2. So I get -2 root 2. Y-coordinate is r sine of theta. So that's -4 sine of negative pi over 4. That's -4 times -root 2 over 2. And so I get positive 2 root 2. So if I superimposed over a xy coordinate system, this point would be -2 root 2, positive 2 root 2, and yes, it is in the third quadrant.